Alright, this is a potential energy well problem. I'm doing this one not because I think this is like a particularly difficult problem to mathematically figure out, but these kind of problems constantly give students trouble conceptually as understanding what's going on. Okay, this is a potential energy well. What that means is that at each of these x locations, there's a certain amount of potential energy is known to exist at that point. Okay? Now in this case, that point we got a ball, 1 kilogram ball, which at x equals 6 has v equals 2, a velocity equal to 2. And we want to find the x bounds. So for example, where is the furthest to the left and the furthest to the right that the ball can go given the amount of energy it has? Alright, so first off we notice two things. We've got to know the total energy. Right? Because total energy, well, mechanical energy, let me rephrase that. We'll go mechanical energy, is equal to potential energy plus kinetic energy. And it's going to be conserved in this potential energy well. All we've got is conservative forces. We know the kinetic energy at a point x equals 6. We know the kinetic energy is 1/2 times 1 times 2 squared, or 2 joules. The potential energy is a little bit interesting to figure out here. We need to know what the potential energy is right here. Okay? And the only way to do that is to figure out the slope of this line. Now we know it goes from -2 to -12, which means that the slope is going to be -2.5. Well, -10 over 4, and it's going to give us -2.5. Okay? And given that we're going over 1, that means we're going to go up 2.5, which means that we know that it is at -9.5, right? Because 12 up 2.5 is -9.5, which means our total energy comes out to be -7.5 joules. Now importantly, you'll see that -7.5 is enough to get it over this hump. Okay, so you don't have to worry about this section. We know it's going to go up and over that. Alright, we're looking for this x value and this x value. So let's look at the left-hand side one first. Key here again is to find the slope-intercept form of that and then solve for our y value of -7.5. So, we can set it up as, well, on the left side, strong side. Yeah, I know. Quote some Remember the Titans. It's a good day. Okay? So we got y equals mx plus b. Okay? We know that b, well, we might not know that b, but I know that b is going to be, well, it's 2.5 rising. Here it's -2. So we go 3 over, that's 7.5. So it's going to come up and it's going to hit at 5.5. Okay, so we know b is 5.5, we know m is -2.5, we get y equals -2.5 x plus 5.5. Okay, and we want to find where y is -7.5. So -7.5 equals -2.5 x plus 5.5, and we should get that x is equal to 5.2, which seems reasonable based on our graph. Awesome. Now let's go to that right side, or strong side. Okay? It's a little trickier. We're gonna have to do. I did point slope form with this. I mean, whatever. Do what you want. Okay? The slope is going to be 4. Okay, and the reason is it starts at -8 and goes to 0, and it goes over 2. So 8 over 2, or 4. Alright, we can then set up the equation as y minus y1. I'm going to use this spot up here as my point because it's going to give it a y1 of 0 equals 4 times x minus x1, which is 19. All right, you should get that y is then equal to x minus 78. If we were then to put in negative 7.5 for y equals x minus 78, we should get that is 17.125 is what x equals to. And that should be a 4. I lost it. Okay? And that's why I'm wrong, because this is 76. There you go. Okay? And that is a potential energy well problem.